And I know that T52 is actually 102, so that's 102 is equal to negative 7 plus 51 times D. Bring the negative 7 over, so that's 109 is equal to 51 times D. My D value is equal to 109 divided by 51. And if you can't simplify the fraction, leave it as is. You do not ever, when it comes to patterns, approximate and like round off and stuff like that. So you always have an exact value. All right, so that's my D value. So I can now plug in my D value into the initial equation that we had here, which used the D value. And that's one way of doing it. But we actually have another way. There is another equation that we can use. And this equation is this one here. If I know my last term in the sequence, I don't even need to use my D value. I can just be like, okay, well, you know what? I know n is 52, so s 52. 52 divided by 2. A is negative 7. And guess what? My last term is 102. Just plug it in. Boom. And just solve it. So that's 52 over 2. That's going to be 95, I believe. Because negative 7, yeah, 95. And now you multiply. So what is this? 52 times 95 divided by 2. And that is equal to 2,470. That means if I add up all the terms in that pattern, in that sequence, I'll get 2,470. And that's it. That's all you gotta do. And let's do it the other way, just to be, make sure that it works the other way too. So I know my D value is 109 over 51. And I don't think I can simplify 109 over 51. So what I'm going to do is, I'm going to draw a circle. Why? Because I wanted to. Alright, so this is my equation here. Gotta memorize it. SN over 2. I think I got it. Wait, what? Oh my goodness. There. So the equation is Sn is equal to n over 2 bracket 2a plus n minus 1 times d. Yeah, that sounds about right. Okay, so this is my initial equation. I know S52, my n value is 52. So that's 52 over 2. My a value is negative 7. My n value is 52. I'm just going to get rid of the circle. (52 minus 1). And my d value is 109 or 51. So this becomes 52 over 2 bracket 2 times negative 7 is negative 14 plus 51 times 109 over 51. And if you realize this, that since I'm multiplying by 51 and dividing by 51, they'll just cancel out. So I'm just left with 52 over 2 bracket negative 14 plus 109. And what is negative 14 plus 109? If I do that, let me see, that's going to be 105, 95. It's going to be 95. And this is actually the exact same step over here. So I know by definition, since that's the exact same step, it's got to give me the same answer. And here we go. So it works the other method as well. So now you have two methods of solving this. And I did that because sometimes you do need to solve your d value. All right, next equation, geometric series. Geometric series is basically same thing as the arithmetic series, except instead of adding all the terms in a pattern that's going up or down by the same, number, common difference, now we're going to add up all the terms in a pattern that are going up or down by a common multiple. So this is the equation for a geometric series. The sum of all the terms n equals a times r to the power of n minus 1 over r minus 1. So let's do this right now. Let's apply it to some basic equations here. Or sorry, not equation, basic pattern here. All right, we got geometric sequence. How do I know it's geometric? Well, the fact that you have -1, +2, and negative, and +2 and negative, that pattern really only occurs when you're multiplying something by a negative value. Because that repeating negative only happens when you are multiplying by a negative value. So my a value is obviously -1. That's just easy. A value is -1. But what's my r value? Well, all you gotta do is take the second term and divide it by the first term. So 2 divided by -1, that's just -2. 4 divided by -4, sorry, divided by +2, that's just -2. 8 divided by -4, that's just -2. So you got -2 all the way through. That means my common ratio is common for the whole pattern. So my r value is -2. Find the sum of the first 5 terms. You know what? 1, 2, 3, 4, 5. I can just add these up myself. I can literally do -1 +2 -4 +8 -8. If I add them all up together, what do I get? Well, let's see. Let's do all the negatives first. So -1, -4, and -16. So it's -16, -4, that's -20, that's -21. Now -21 plus 8 plus 10, that's going to be +10. So -21 plus 10 is -11. So I should get -11. Let's see if that's true. Let's see if I do get -11 using the equation now. So S5 is equal to A, which is -1, R, which is -2, and N is 5. So -2 to the power of 5 minus 1 over R, which is -2 minus 1. And here it's important to put brackets around this because it's R to the power of N. And since R is -2, it's inside the brackets. Very important because this will change everything if it's a positive or a negative exponent. So this is going to be -1 and -2 to the power of 5. Since this is an odd exponent, I know it's going to be a negative value, and it's actually -32 minus 1, and that's just -3. So that's going to be -1 times -33 over -3. That's just positive 33 over -3, which is -11. And guess what? That's the answer that I had initially as well when I add them up, -11. So here's an example of a geometric sequence and then a geometric series. So, yeah. And now they're saying just find S13. Well, yeah, that's just simple. Just do the exact same thing, except now my n value is 13. So S13 is equal to, see the same values here, -1, -2 to the power of 13 minus 1, all over 13 minus 1. Sorry, I made a mistake. It's r minus 1, so it's not 13 minus 1. It's my r value is -2. Okay, so -2 to the power of 13. I know 10 is 1024, so 248, 496. And since it's an odd value, it's going to be negative. Obviously, you have -1, and then obviously multiplying by -1. But since I don't trust myself, I'm going to do 2 to the power of 13. And no, I was off by 1. Damn it. So yeah, 10, 11, 12. Yeah, you're right. Damn it. I did 12. Foolishness. Yeah, that actually makes a lot of sense because. Sorry, guys. 8192. All over -3. And that's just going to be -8193. And since I'm multiplying by -1, I'm just going to change it. I'm just doing that multiplication right now. Divided by -3. And let's do that. What is this value? 8193 divided by 3. And the answer is 2,731.